Reasons for structures to collapse are bad design, faulty construction, foundation failure, extraordinary loads, unexpected failure modes, or a combination of causes. But failures also occur due to natural disasters such as earthquakes, floods, hurricanes, cyclones, and fires. The St. Francis Dam was a curved concrete gravity dam, built to create a large regulating and storage reservoir for the city of Los Angeles in California. The reservoir was an integral part of the city's Los Angeles aqueduct water supply infrastructure. It was located in San Francisco Canyon of the Sierra Pelona Mountains. At 11:57 p.m. on March 12, 1928, the dam catastrophically failed, and the resulting flood killed at least 431 people. The collapse of the St. Francis Dam is considered to be one of the worst American civil engineering disasters of the 20th century and remains the second greatest loss of life in California's history. An investigation into the disaster concluded that it had been caused primarily by the unsuitability of the San Francisco rock for supporting a dam and a reservoir. The Tacoma Narrows Bridge in Washington collapsed only 4 months after opening for public use. The bridge spanned the nearly mile-wide Puget River, making it the third longest suspension bridge in the world, next to the Golden Gate Bridge and the George Washington Bridge. While the original designer intended to create greater stability with a more standard design, the cost was unreasonably high. Instead, a cheaper option using plate girders gained approval. The girders, though, were only 1/3 the height of the originally proposed trusses, which resulted in a disproportionate depth-to-width ratio. As a result, the bridge was extremely flexible and vulnerable to high-speed winds. In the morning of November 7, 1940, an 40 miles per hour wind struck the Tacoma Narrows Bridge that caused the bridge to twist and buck wildly. The bridge finally gave way, snapping the support cables and dropping into the river below. The building was a much-anticipated landmark designed by a well-respected architect, but was known in the 1970s for its engineering flaws as well as for its architectural achievement. The opening of the building was delayed from 1971 to 1976, and the total cost is rumored to have increased from $75 million to $175 million. It was an embarrassment for the firm, for modernist architects, and for the architecture industry. There were problems with the innovative use of blue reflective glass in a steel tower. The entire 4 feet by 11 feet window panes detached from the building and crashed to the sidewalk hundreds of feet below. Police closed off surrounding streets whenever winds reached 45 miles per hour. The research raised questions about the structural integrity of the entire building, and an independent laboratory eventually confirmed that the failure of the glass was due to oscillations and repeated thermal stresses caused by the expansion and contraction of the air. The resilient bonding between the inner glass reflective material and outer glass was so stiff that it was transmitting the force to the outer glass, thus causing the glass to fail. In October 1973, Io Ming-Pei and partners announced that all 10,344 window panes would each be replaced by single-paned, heat-treated panels. It took many months to diagnose and repair the building. Sheets of plywood replaced many of the missing glass windows of the building, earning it the nickname Plywood Palace and Plywood Ranch. Bostonians joked that the Hancock Tower was the world's tallest plywood building. On July 17, 1981, 2 walkways collapsed at the Hyatt Regency Kansas City Hotel in Kansas City in Missouri, United States, one directly above the other. They crashed onto a tea dance being held in the hotel's lobby, killing 114 and injuring 216 individuals. This disaster contributed many lessons to the study of engineering ethics and errors, and to emergency management. The event remains the deadliest non-deliberate structural failure in American history, and it was the deadliest structural collapse in the United States at that time. The Kansas City Star hired architectural engineer Wayne G. Lisker to investigate the collapse, and discovered a significant change to the original design of the walkways. The NBS's final report cited structural overload resulting from design flaws where the walkways had only minimal capacity to resist their own weight. Investigators found that the collapse was the result of changes to the design of the walkway's steel hanger rods. The two walkways were suspended from a set of 1.25-inch diameter steel hanger rods. This design change would prove to be fatal. In the original design, the beams of the fourth-floor walkway had to support only the weight of the fourth-floor walkway, with the weight of the second-floor walkway supported completely by the rods. In the revised design, however, the fourth-floor beams supported both the fourth and second-floor walkways, but were only strong enough for 30% of that load. On June 4, 1979, in the same facility that once had hosted the Republican National Convention, nearly a third of Kemper Arena's roof collapsed during the rainstorm with 70 miles per hour winds and heavy rains. A supervisor had observed water pouring in and the scoreboard falling. Finally, a large area of the roof collapsed onto an unoccupied seating area. Since the arena was not in use at the time, no one was injured. After investigation, it was found out that the collapse was triggered by fracture of the high-strength bolts, part of the hanger that suspended the roof from the space frames. Analysis demonstrated that failure of just one of 4 bolts per hanger resulted in a large prying load on the 3 remaining bolts that caused to collapse. During the 20 Fenchurch Street construction, it was discovered that for a period of up to 2 hours each day, if the sun shines directly onto the building, it acts as a concave mirror and focuses light onto the streets to the south. Spot temperature readings at street level including up to 91 degrees Celsius and 117 degrees Celsius were observed during summer in 2013, when the reflection of a beam of light up to 6 times brighter than direct sunlight shining onto the streets damaged parked vehicles. Temperatures in direct line with the reflection became so intense that City AM reporter Jim Waterson managed to fry an egg in a pan set out on the ground. The reflection also burned or scorched the doormat of a shop in the affected area. The media responded by dubbing the building the walkie-talkie building for its design and skyscraper building. The building won the Carbuncle Cup in 2015, awarded by Building Design magazine to the worst new building in the UK during the previous year. The building eventually had to install screens at certain points to prevent the reflection of direct sunlight. During the wedding of Karen and Asaf Dror in May 24, 2001, a large portion of the third floor of Jerusalem's 3-story Versailles wedding hall collapsed. As a result, 23 people fell to their deaths and 380 were injured, including the bride who suffered serious pelvic injuries that required surgery. The disaster shocked the Israeli public not only because it was one of the worst building disasters in the country's history, but because the event was documented on a camcorder and broadcast on local and international television. An investigation of the event concluded that it was not caused by a terrorist attack as suspected. Witnesses reported seeing a dangerous sag in the floor moments before the collapse. Initially, the side of the building that failed was designed to be a 2-story structure, while the other side was designed to be 3 stories. Late in the construction process, it was decided that both sides of the building should be equal heights, and a 3rd story was added to the shorter side. However, the live load due to occupancy is typically much greater than the design load for a roof. As a result, the structure supporting the new 3rd story was subjected to much greater loading than was originally anticipated. The effect of this error was somewhat mitigated by the construction of partitions on the floor below, which helped redistribute the excess load well such that no damage was incurred. During the wedding event, this significantly overstressed floor section failed, resulting in a catastrophe. Construction of the Tower of Pisa occurred in 3 stages over 199 years. On the 5th of January 1172, the tower began to sink after construction had progressed to the 2nd floor in 1178. The 7th floor was completed in 1319. The bell chamber was finally added in 1372. The Tower of Pisa began to lean during construction in the 12th century, due to soft ground which could not properly support the structure's weight, and it worsened through the completion of construction in the 14th century. By 1990, the tilt had reached 51/2 of a degree. The structure was stabilized by remedial work between 1993 and 2001, which reduced the tilt to 3.97 degrees. Numerous efforts have been made to restore the tower to a vertical orientation or at least keep it from falling over. Most of these efforts failed. Some worsened the tilt. On the 27th of February 1964, the government of Italy requested aid in preventing the tower from toppling. It was considered important to retain the current tilt, due to the role that this element played in promoting the tourism industry of Pisa. Starting in 1993, 870 tons of lead counterweights were added, which straightened the tower slightly. At least 4 strong earthquakes hit the region since the year 1280, but the apparently vulnerable tower survived. The reason was not understood until a research group of 16 engineers investigated. The researchers concluded that the tower was able to withstand the tremors because of dynamic soil-structure interaction. The same soft soil that caused the leaning and brought the tower to the verge of collapse helped it survive. In 1987, the tower was declared a UNESCO World Heritage Site. The tower has also been called one of the 7 wonders of the medieval world. Thanks for watching, and God bless.